You are with Cape Talk.
Views and News with Clarence Ford.
Welcome back. It is 9:35, and our big appointment with the naked scientist, Dr. Chris Smith, a lecturer at the University of Cambridge, and he puts aside a half an hour of his very busy time for us to answer our questions. And we've got plenty of questions, and I know you may not have registered yours. There's still some time for you to do that via WhatsApp on 072 567 1567. Hey, if you want to beat the queue, and the queue is growing, you can call on 021 446 0567 and you'll jump the queue. 9:35. Good morning to you, Chris. Great to have you back.
And this is the week, isn't it? We see the paper in the journal Nature saying, "Is there life on Mars?" Was David Bowie right all along? You must have seen
It
the
is
headlines.
the
What
week,
was
is
your
it
take
not?
on it? I spoke to the guy who wrote that paper yesterday. It was an amazing experience, actually.
Well, I told you so. No, I think, yeah, we're looking at microbial life, and I always thought there would be a chance of that.
Well, I spoke to Sanjeev Gupta. He's at Imperial College in London. And the reason we were chatting is because we know each other. I first met him about 20 years ago when he published this amazing paper working out where the Straits of Dover, that basically was the first example of Brexit, came from, how the UK got separated from mainland continental Europe when a dam burst, a sort of ridge of rock, and allowed all this meltwater to come rushing and roaring through the English Channel, and it carved out the Straits of Dover. So that's how we knew each other. So he has form looking at minerals and geology on planets. Now he's taken that farther afield, millions of miles away to Mars. But it's a really interesting discovery, this, because they've been using these rovers that are trundling around on the surface of Mars, in this case Perseverance, and they are looking in craters. The reason for going for craters is because when you have a crater, the impact discloses or breaks down various layers or strata in the surface of the rock. Because if you can just look at the surface, you can only see so much. If you go to a crater, because of the impact cutting away layers of rock, you're effectively seeing back in time. And in this case, billions of years to perhaps 4 billion years ago, when Mars was very young and a very wet place. And what they've been able to see, now admittedly this is just C, very limited chemical analysis at this stage, but what they can see are these things they're dubbing leopard spots. Because on the surface of various parts of the rock, you can see these dot patterns with a ring around them, like a target. And you might say, well, what's special about that? Well, on Earth, we see this kind of pattern where communities of microbes eat organic matter, and they can see that there's carbon-based organic matter in these spots as well, using a different instrument on the Perseverance rover. And as the organic matter is consumed, it liberates various other minerals and chemicals that other communities of microbes can then use. And you get almost like a frontier point where one group of chemicals meet another group of chemicals, and the environment leads to a set of chemical reactions that produce the ring pattern. Now, there are non-life-based processes that will produce a similar pattern, and we know about that, we've documented that, but the temperature you need for that to happen is way beyond what sorts of temperatures we would anticipate would have been happening on Mars at the time when these things were being made, which is why they're saying this is a good smoking gun for the discovery of microbial life. The key thing here is that, and this is past microbial life, the key thing is that they've got samples from these things now, but those samples are not coming home here to Earth to get analysed properly, to really and definitively say what they are, for decades. So most people who are publishing and reading this paper, they're not even going to be here by the time that sample gets back. So it's a safe bet for them. Probably a good way of getting a bit more grant money. But let's hope it is signs of past life on Mars, because it opens up a wonderful chapter in our understanding of the origins of life, the formation and evolution of life. And won't
Sure.
it be amazing to study what that
And
has done?
does it settle the debate in your mind?
No, because at the end of the day, while seeing is so much, you need to have multiple strands of corroborating evidence. I've already explained to you that there are ways in which this could happen via non-life processes. So one always has to remain skeptical until you have eliminated all traces of doubt. I think it was Spock in Star Trek who said that, wasn't it? That, you know, when all things have been excluded, what remains no matter how
Yeah.
improbable, must be the answer. Well, this is sort of similar. There are other possibilities here. It's tantalizing and it's a wonderful thing to go for in the future, but we're not going to know until those
I want to
samples get analysed
extract.
properly.
I want to extract a concession from you. Is it the best evidence to date?
Well, it's the only evidence to date, really. The previous
Okay, then it's the best as well.
the
I'll take even
the
that.
previous samples. If you remember back in the 1990s, late 80s, there was the ALH 84001, Allen Hills 84001 sample. This was a rock that had been documented. It was actually a piece of Martian rock that we'd got our hands on because it ended up here as a
Yes.
meteorite, and it had these things in it that looked like microbes or worms. And people said, is this Martian life, fossilized Martian life? And it created enormous amounts of fanfare and furore. But subsequent analysis showed, well, there are geological processes that probably could account for how that came about. So we've been down this path before. It wasn't just H.G. Wells saying there's life on Mars and it's coming to invade us. We've had many such reports and speculations in the past. What we need is evidence. And here we have a really exciting thing to go after, but we're not going to know for many years yet for sure.
I'll take the excitement then, if that's all I'm going to get. Let's go to that voice note in from Jason. Joe?
Hi, Clarence. Trust that you are well. It's Jason here. Quick question for the great doctor. What is the purpose of fingernails and toenails? Why do we have nails?
Oh, well, what would you pick your nose with otherwise, Jason? Not with your feet, I hasten to add. But no, I mean, the point is, fingernails, they're weird, aren't they? I mean, they grow at a fraction of a millimetre every day. They are made of the same stuff that our hair is made of, keratin. And what do we do with them apart from clip them? Well, actually, they're really useful. They improve grip. And although people bite them, they probably shouldn't because that's a great way of picking up germs. But they're very good for stabilizing and strengthening and stiffening the ends of your digits, which gives you better grip. So when you apply your fingers to a surface, instead of the surface deforming so much, you actually have got an ability to get hold of things better. So they do improve grip. They also make your toes have a better grip on the floor by stiffening the toes. We don't need that so much in the modern era because we wear shoes, but historically it would have been much more useful to us. And obviously the exaggeration of fingernails in animals is claws, and they use those both for defense because you can stick them out and then scratch things, but also to get a grip, as I've just suggested. So we've slightly changed that we don't go around attacking people with our fingernails quite so often these days, thank goodness, like animals would use their nails for, but they enhance grip in animals. They do that to a certain extent in us too.
Okay, Keith wants to know why athletes run anti-clockwise on a track. Is it because the Earth spins in a clockwise direction?
No, just convention. And it's really interesting. People have looked at horses because some horse races are run clockwise, some are run anti-clockwise. And it turns out that horses have a handedness like humans do some of the time, but not in the same way we have 90% of the population are right-handed, 10% left-handed. In horses, it's about 50-50. But it really makes a difference because when the horses run a racetrack that is the opposite handedness to their hoofedness, I suppose you'd say, they don't do as well. Now, it might be a coincidence, but it seems a bit unlikely given the number of tracks and races that people have analysed. So horses have hoofedness, humans have handedness. We also have strange traditions and conventions, and we run races that way. I can't think of any other reason. It's nothing to do with the spin of the Earth. We've been running races for longer than we've known what the Earth was doing.
True. Hello, Naked Scientist. I recently bought myself headphones that I use in the water whilst swimming laps. Can you explain how bone conduction headphones transmit sound to the inner ear without using the eardrum? From Tundo in Johannesburg.
Hi, Tundo. Well, a really good example of bone conduction at work is listen to a recording of yourself on a cassette tape from the old days, an MP3 player in the modern era, your mobile phone, and you'll go, oh my goodness, is that me? Do I really sound like that? Why do we sound different when we hear a recorded rendition of ourselves compared to when we're just talking? That is the effect of bone conduction. What happens when we hear is that our ears, which are effectively giant funnels, bigger in some people's cases, are diverting sound waves, vibrations from the air down into your ear canal. As the vibrations travel down the ear canal, they effectively get amplified because you're narrowing a big collecting area into a small area. The sound waves impinge on your eardrum, which is a flat sheet of tissue, which is connected via a chain of 3 small bones, malleus, incus, and stapes, to your inner ear, which is the thing that converts vibrations into electrical waves that the brain can understand. Now, when we listen to sounds coming from the environment, we are getting chiefly sounds vibrating through the air. But when we listen to our own voice, we are also making our skulls vibrate with the sounds of our voices. So you also get waves travelling through the bones of your skull into your inner ear, and it colours the sound, which is why we think we sound different to when we listen to ourselves. But with bone conduction, what you're doing, instead of relying on the air waves to make the eardrum vibrate and then transmit those vibrations to the cochlea, you make vibrations go into a patch of bone. It travels very nicely through the bone and then reaches the cochlea via that route. No need for airwave vibration. So a nice demonstration on your own voice of seeing this in action, but that's basically the physiological basis.
Brian writes, a magnet is not attracted to aluminium, but when a bar magnet is allowed to slide down an aluminium sheet, I think he may be referring to his fridge, it is slowed down compared to a similar size piece of mild steel. Can you explain this reaction?
Hi, Brian. Yes. Right. So aluminium is not ferrous. It's not iron, as Brian correctly points out. And ferrous materials are susceptible materials. In other words, they can be made into magnets. But aluminium, as a metal, is an excellent conductor of electricity. And when you slide a magnet down a conductor of electricity, whatever it's made of, that conductor is seeing a changing magnetic field, because when you move a magnet, you're moving the field that the magnet is making past the conductor. When a conductor is in a moving magnetic field, this makes charges move inside the conductor, and if you have moving charges make an electromagnetic field. So what's actually happening to Brian's magnet sliding down the refrigerator, and great observation by the way, is that he is making a magnetic field in the fridge, which is sticking to the magnetic field from the magnet, and the interaction of the two fields, one repelling the other, slows down the passage of the permanent ferrous magnet as it goes down the fridge. So he's inducing an electromagnet, effectively, temporarily, in his fridge.
Then a message in from Andre writes, what role did our teeth play in our evolution and extinction of human development?
Well, the teeth played a massive role and have in all species. And this is why if we look across the world at all animals and even invertebrates, they have teeth. And they use them for defense and fighting, looking scary, and obviously digesting it, helping to digest dinner. You tear your prey apart, having caught your prey with your claws that we talked about earlier, and you mash it up with your teeth. Without teeth, you could not get calories into your body or stop your body becoming someone else's calories. So teeth have played a huge role. We are derived from the same animals that invaded the land millions of years ago, hundreds of millions of years ago. They gave rise to us. They had teeth. We've carried on adapting and modifying those structures in order to make them optimal for the way we live our lives, and other animals have made teeth optimal for the way they live their lives. And if you're a herbivore and you eat lots of grass and plants, you tend to have teeth that are very good at grinding things up. And if you are a meat eater, like a lion, then you have teeth that tend to be very, very sharp and very good at grabbing things and then ripping flesh off of bones so you can eat it. And our teeth are a halfway house between the two because we have an omnivorous diet. We eat bits of meat. We also eat bits of plant. We're omnivorous in that way. So we have teeth that are a halfway house between the two, but not as big as they used to be historically, thank goodness. And that's because we've adapted in how we live our lives. We cook food, we prepare food, we farm food, and our behaviour has selected for smaller teeth over time, and our genus Homo has the smallest teeth of all of our ancestors.
A question in from Lou. Dear Dr. Smith, I'm 66 years old. I recently lost 16.5 kilograms of weight, which is unusual, and muscle mass on my legs and my buttocks. I'm suffering from diabetes. Also, can my weight loss be contributed to the diabetic condition?
Oh dear. Well, I'm very sorry to hear that. Weight loss that you don't intend to happen at any time is always worthy of investigation and must be looked into. Because if you're intending to lose weight, it's one thing. If you're not intending to lose weight and you've lost a considerable amount, which it sounds like you have, something's up and you need to go and get that checked out. Now, diabetes is a very common way to lose weight if it's uncontrolled, because what's happening with uncontrolled diabetes or poorly controlled diabetes is you're running blood sugars which are too high. The normal level of blood sugar needs to be about 5-ish, and if it goes above 10-ish, our kidneys cannot pull back into the bloodstream more than a level of about 10 millimolar of glucose. Once you're over 10, you cannot get all the sugar back. So you get more sugar going into your urine, and that means you're losing sugar. If you're losing sugar, you're losing energy. If you're losing energy, you're losing weight. And so it might be that the diabetic control needs optimization. It might be there's something else going on as well. It's definitely worth getting this checked out, please.
I'm so glad that T has asked this question, because it's the one question that I wanted to put to you as a follow-up question. It reads, follow-up to bone conduction. Why do we generally dislike our voices when we hear what they actually sound like?
Well, you'll know this, Clarence. I mean, you tell me honestly, when you hear recordings of you back on the radio, do you maybe you do sort of buff your colleague, go, oh, isn't that just amazing? Or do you think, oh,
No.
Even to this day, I've been making radio programs for over 25 years. I listen to myself on the radio and I think, I still cringe. And as one colleague of mine, as one colleague of mine put it to me, he said, the best you can ever hope for is to learn to tolerate the sound of your own voice. And I think it's not your voice, everyone. And I think that what he's getting at is that because we are so used to the way we sound ourselves when we hear ourselves talking, because we're hearing both a combination of air conduction, the sounds come out of our mouths, become vibrations in the air, go to your ears and go in that way, plus the bone conduction. When we hear a recording of ourselves, A, we're listening much more carefully because it's us who said it, so we're being much more strict and critical about it. But B, it sounds so different, we notice everything, and hence our level of critique goes up. And we find it very, very awkward to listen to ourselves because it doesn't sound like us, but it is us, and we know it. And we're very tuned into when our expectation doesn't match with reality. And that tends to make us pay a lot more attention. And I suspect that's partly what it is.
Yeah, I've been in this business for a while, and I still hate it. So every Thursday at about 12:15 is the most traumatic half hour of my week. That's when Tessa, my boss, listens to what I say, and I can't believe that I have this job. But let's go to Roger. Also a follow-up question from an earlier question, or maybe from your introductory chat. Is it not possible for astronauts to create an environment for life on Mars so future generations of explorers can then find lots of life on the planet? That's Elon's mission, is it not?
We could do that tomorrow if we wanted to. We've got habitats, we've got the technology, and in fact, I was talking to a group of people this week for the next episode of the Naked Scientist podcast, which we've called Made in Orbit. We're looking at things that we're outsourcing off planet now, and one of them's making homes. So people are talking about making houses in space, and I talked to a lady who worked for NASA at home, their project to produce homes from home. We've got all the technology. There've been people living continuously on the International Space Station for 25 years now. So we can live in space if we want. If we can live in space, we can live on Mars. The problem is, it's not easy to get there, not necessarily safe to get there, and it's not necessarily nice to live there, and you wouldn't be coming home because at the moment we don't have reliable tech to get you back. So you'd have probably a 9 to 12 month journey getting to Mars. You'd probably, based on measurements made by the Curiosity rover mission about 15 years ago, they sent when Curiosity went to Mars, they used the radiation detector on Curiosity during the journey to measure how much radiation Curiosity was seeing. And if it were a person, it would have had basically an entire lifetime's worth of safe radiation exposure in just 9 months getting to Mars. So you would be irradiated at the moment if you got there. That wouldn't be good. And when you got to Mars, yes, we could build a little house for you, but it's cold. Average temperature about 0. There's nothing to see apart from an undulating landscape of rocks and bare earth. It's a red kind of cruddy, not very bright sunshine in the sky, and the company might be awful. I mean, can you imagine that? There's no talk. There's no Cape Talk there. You'd have to get that over the internet, and the time it takes the radio waves to get to Mars. If you and me wanted to do a phone in, we'd be waiting about 10, 20 minutes for each question to come in, and then the person would get their answer, and you'd never say to a caller, "Is that okay?" Because then you'd have to sit there for about 20 minutes while you found out if it was okay, if the answer was up to scratch. So, I'm not going, but in the future, people will.
Okay, let's end off with this fun one. Rafik wants to know what is wrong with a pear shape. That when things go wrong, it makes people say that things have gone pear shape.
Well, it's droopy, isn't it? If you think about the shape of it, like a raindrop, if you were to put some paint on the wall and it sagged, or if you had some curtains and they sagged, if you look at your belly in middle age, it sags, things go droopy. And I think it's because when things go south, another way of saying things have fallen over, they go pear-shaped. And I think that's where the analogy comes from. But if anyone knows better, if anyone who's a proper linguist and knows better, do share for next time.
I've got to play Ingrid's voice note because I think there's a lot of singers that would probably feel the same thing or way.
I am clearly highly unusual. I love the sound of my voice. Am I a narcissist?
Yes. No, I thought this because I interviewed once John Anderson out of the group Yes, because I was interested in he ended up having a gig cancelled because of the moon landings. So he said there was competition over the plug socket in one of the venues. So they all went to the pub, and instead of playing their Yes gig, they watched the moon landings in the late 60s. And I was recording this, and I got him to sing a bit for me. And I looked at the recording of the singing, and I was looking at the audio waveform. It's absolutely brilliant. And I was saying to him, do you ever get tired of listening to your own music? And he said, well, you have to be very, very critical. But no, you actually learn to quite like the way you sing. And so I suppose it takes enormous confidence when you're a professional performer like that. I think it's a bit different than when you're just...
especially.
Exactly.
If you've got other instruments to blend into, maybe there's some other kind of confidence that you can lean into. But yeah, okay, so narcissistic then is your final answer.
No, yeah, I think maybe you're just a professional opera singer or something. Well-trained voice.
Absolutely. We got to wrap it there. Dr. Chris Smith, the Naked Scientist, every Friday just after 9:30, and it's appreciated, as always.
You are with Cape Talk.
Views and news with Clarence Ford.